Hello and good day to Dr. Samsuhendra as our lecturer for this subject SBEQ3173 Civil Engineering Construction subject. Welcome to our video presentation of Water Reticulation System for our group assignment. We are from group 14. Our members are Hanisa binti Bustami, Jerome Emelene Ana Patrick, Nur Atirah binti Abdul Malik, Nur Syamimi Amirah binti Zainal, and Wadatul Kristina binti Suhaimi. So here is the content for our presentation today. At first, we will present the introduction part, and then we move to the next part, which is what is the water reticulation system, the design consideration, standard specification for water reticulation system, and the main part for our assignment, which is the case study, water reticulation system for Tun Razak Exchange, TRX. So for the first part is the introduction. As what I have mentioned before, our case study is based on the Tun Razak Exchange contract, which is the proposed construction and completion of infrastructures and roadway works. In the water reticulation system, water is usually delivered through an infrastructure that mainly consists of pipes that are made up of plastic, concrete, or metal. Pressure will create an energy that will allow the water to be delivered to its destination. Here in Malaysia, the government owns these water reticulation systems, which are designed by town planners, engineers, and consultants hired to sketch a detailed plan of the system before they can install and implement it. Several factors need to be considered by the professionals to implement those systems are such as the size of pipes, location, future expansion, the risk and probability of leakage, and also the pressure. And this will be presented by my group members afterwards. From the aspect of cost, all of these considerations will affect the operational cost of the system later. To cut the cost, the gravity factor can be considered as it will allow the water to flow from the elevated reservoir where it will then be dispersed and controlled by valve. Thus, gravity is always recommended as it is reliable and often chosen by planners and engineers to drive this water reticulation system.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Atira binti Abdul Malik, and for this part, I'm going to explain about what is water reticulation. Okay, as we know, water reticulation is a water distribution network that collects and cleans water before distributing it to the consumers. Nowadays, water systems are often distributed via an infrastructure consisting of pipes that is made of materials such as plastic, metal, or even concrete. Water is typically transported to its destination using pressure and the energy generated by that pressure. These delivery networks are usually owned by local governments. Before the installations can begin, the system must be developed and planned by the municipal planners, city engineers, and also consultants who are contracted to work out every detail of the system. The size of the pipes to be utilized, the position of the pipe, plans for the future extension, calculation of the possibility of leakage, various pressure variables, and how close these systems are to fire departments are all factors to consider while implementing the system. Next, the gravity can be employed to be help with this movement, which is advantageous for a less expensive process. It will allow water to flow from the elevated reservoirs and then be dispersed and controlled via the valves. Moreover, gravity flow systems are often chosen and regarded as always trustworthy. To select the proper system, it is critical to evaluate the pump type as well as its capacity and the ability to keep control of the water's movement. The system materials such as the pumps, tanks, and other components are easily interchangeable. Buried pipelines are used for a longer period. PVC, polyethylene, galvanized, or black steel and copper are common materials utilized in the construction of these systems. When choosing a pipe, firstly, we must examine its life expectancy. Next, safe operating pressure and ease of bending and installation, cost, and the type of the pipe connection required. And it is also a good idea to choose a pipe that is resistant to corrosion, soil movement, and also vehicle loads. Further with our study, a water reticulation system might be difficult to design. Air relief valves, vacuum relief valves, isolation valves, water storage and truss blocks, as well as pipeline and fittings should all be located by the designer. Water reticulation system can be either gravity flow, pressurized, or, or a hybrid of the two. Firstly, we go to the flow of gravity. The water storage in a gravity pipeline system is higher than all places in the delivery pipeline, and there is no pump required for the downstream of the storage. The water supply, for example, might be positioned at the highest point on the property and the conclusion of a pump conduit. This is the ideal approach for supplying drinking water to livestock because it is less reliant on infrastructure. A gravity system is typically installed on a positive gradient in the direction of flow over its entire length. Installing air valves or standpipe vents at a significant high points in the pipeline prevents the airlocks. If the pressure is too low, the air valve will not function. And for the second reticulation system, we go to the system under pressure. For this system, pumps are typically used to transport water from a borehole or a stream, we know as creek or a river, to a higher elevation storage facility or to pressurize the water system to supply it through a pipeline around the building. Pump types such as centrifugal, turbine, and positive displacement. For the pump capacity, it is either single, multi-pump, distance, and amount of water to be moved. And the pump control are all design factors in a pressurized system that also can be found in automatic pressure, timed, and also manual. Next, we go to the pipeline network system. A pipeline network is a collection of interconnected elements such as pipes, compressors, pumps, valves, regulators, heaters, tanks, and also reservoirs. Pipeline networks transport crude oil, natural gas, water, and petroleum products in large quantities. And the pipe and valve networks are an essential component of pressure relieving and fire water systems is designed to handle the contingencies in the operation of the process units. And it is also designed to carry the amount of water required by the length of the pipeline, the elevation difference, and also the demand for the water at each outlet. Plus, pipeline dimensions and characteristics must be established for each system depending on the site and system requirements. Next, in our research, there are three types of distribution network types that have been used in water reticulation systems, which are the branch network systems, grid patterns with loop systems, and also the dead-end network systems. Firstly, we go to the branches network system. This network is analogous to a tree's branching and is made up of a main, we known as trunk, mainline, submains, and also the branches. The mainline serves as the primary source of the water supply. The mainline provides no water distribution to watering locations, and the submains are connected to the mainline and typically found along service or feed delivery routes. For the watering points, it is positioned on the branches which are connected to the submains. Additionally, branch network are very economical pipe dimensions that only induce fewer cut-off valves in the systems. However, using a branch network also comes with the disadvantages. For example, if the area or zone that receives water from a damaged pipe, it will be without water until the repair is done. And when delivering drinking water to a building, this can be a serious issue because there is no water to be delivered to the consumers. Secondly is the grid patterns with loop systems. All of the pipes in the grid pattern with a loop supply system are interconnected in loops with no dead ends. Water can reach any place from many directions, ensuring supply in the event of pipeline obstruction or breakage, as well as more even pressure at all outlets. Additionally, the advantages of using grid patterns are the stagnation is reduced since water in the supply system can flow in more than one direction. Hence, in the event of a pipe repair or break, water will flow to a region from another direction. As a result, the sections of the water line can also be disconnected for maintenance, while water can still be distributed to other watering locations. But despite that, the advantages in using these grid patterns, it will increase the expense of pipe infrastructure due to the need for the additional pipe, and this will lead to additional valve being required. Furthermore, calculating pipe sizes can be more difficult to ensure adequate flow rates and pressure at all sites or off-take points. A pipe network study may be required. And lastly, we go to the dead-end network systems. The name dead-end system implies that it contains dead ends in the pipe system. As a result, in the dead-end system, the water does not flow continuously. The entire pipe network is divided into several sub-networks in this system. Main lines, submains, branch lines, and also service connections are examples of the dead-end network system. A few advantages can be found, which are the pipes can be easily laid in this network. Besides, the pressure and discharge in each pipe can be determined quickly and accurately, making design calculations a breeze. The diameters of main, submain, and also the branch pipes can be designed to meet the populations needed. As a result, the project cost can be reduced, and also the dead-end system necessitates fewer cut-off valves. Conversely, when using the dead-end system, there are also the cons in the usage, which is the pressure does not remain constant and is very low in remote areas. Moreover, water stagnation occurs as a result of the dead ends, resulting in sediment disposition. If there is any damage to the branch line, the entire section should be shut down to repair what is causing discomfort to the other users that sub-main line. And also, this system is no longer preferred due to the complications of the usage.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wada Angeliki Suhaimi. Next, I will be explaining about the design consideration of water reticulation system. To ensure the workability and functionability of water reticulation system, some factors must be taken into consideration. Firstly, the sizing and specification of pipeline. The water pipeline network for each segment must provide the required amount of water at an acceptable pressure to each water delivery outlet. Hence, the diameter and length of a segment of water system are important to control the pressure. Besides, operating pressure, pressure surge, and the pipe strength must be taken into consideration to determine the pipeline specifications. Also, the relative heights of the water distribution station may have an impact on the sizing. Next, materials also are one of the factors that must be taken into account. Materials are very important to ensure the quality of the pipe and fittings, and pipe size must be sufficient to meet the fitlet's final size. Materials such as polyethylene, PVC, galvanized steel, mild steel, and copper are the common materials used as pipeline. Some factors are considered in choosing type of materials are the life expectancy, the corrosion resistance, resistant to deposits forming inside the pipe, safe working pressure, resistant to puncture and soil movement, resistant to vehicle loads, ease of installation, and also the type of pipe connections. Thirdly, the air relief valve. An air relief valve must permit air to be released automatically from high locations into water line, ensuring that the water flow is not obstructed. With that, the air can be discharged at a water delivery point if the water line velocity is high enough to force the air through the line. Furthermore, vacuum relief valve also is one of the factors to be considered. This is because a vacuum relief valve prevents suction in the line from causing the pipe to collapse or break when there are considerable changes in elevation. Advice on the location and requirements for check valves and air release valves should be sought. This is to ensure that the suitable pipe class is chosen. The pressure head should be also determined. Next, shut valve must also be considered in designing a water reticulation system. This is because, with the existence of a shut valve on each row of the pipeline, maintenance on a sub-main can be done without affecting the entire feedlot. Shut-out valves on each unit should control the water supply to each trough. Valves should be put at the system's lowest point to allow any collected residue in the pipe network to be flushed out. On top of that, location is one of the most very important consideration. Pipeline locations should be marked in a post-construction survey. This is because an accurate map of established pipes, valves, and off-take points is a crucial tool for limiting damage during future earthworks. Here are some of the aspects to be considered for location. The location must be far from physical damage from livestock or machinery, and it must have an accessibility for maintenance or repairs, and it is advised to find a location which minimizes water heating. In addition, water flow meter is also a very component to be installed in a water reticulation system. This is because water flow meter is very important to monitor the resource efficiency. Water usage should be documented on a regular basis using flow meters. Water flow meters are normally installed in a straight length of pipe with 10 pipe diameters upstream and 5 pipe diameters downstream of the meter. Also, water usage should be tracked on a regular basis using water flow meters to monitor the resource efficiency. Lastly, the maintenance. Regular inspections and maintenance of the watering system should guarantee that livestock has an appropriate quantity of water at all times. Leaking troughs, pipes, and float valves are all common issues that can typically be fixed quickly and cheaply.
So now we come to the main part of our assignment, which is the case study of the water reticulation system For Tun Razak Exchange TRX project. For our case study, we choose this water reticulation system, which is located at Kuala Lumpur, as in the proposed construction and completion of infrastructure and roadway work contract. The main project of this Tun Razak Exchange TRX includes 26 buildings and more than 21 million square feet of gross floor area (GFA), which consists of office lots, residential, hotels, retail, and cultural offering. As in our project, we will just focus on the construction of water reticulation system. TRX City Sdn Bhd realized that the development of TRX is in a dense urban area or city center, and they must ensure that the conservation remains the priority. One of the aims of TRX is to adopt renewable resources technology that will enable at least 80% of its sewage-generated water to be reused within the new financial district. Next, I will move to the background of the project. Our case study is based on the proposed construction and completion of infrastructure and roadway works at Tun Razak Exchange, which is located at Section 62 and Section 67, Jalan Davis, Wilayah Persekutuan Kuala Lumpur. The site possession began from 21st October 2015, and the original practical completion date should be 7 September 2017. Due to some delays, extension of time EOT has been granted, and the new completion date was 18 June 2019. However, the project was delayed again, and the new practical completion date is 18 September 2022, which is based on the latest EOT application, EOT number 9. The original contract sum of this project was 754 million 833,091 ringgit and cent 97. But after some changes and revision based on the latest IPC number 46, the new contract sum decreased to 695,629,211 ringgit and cent 1. As per inspection on 19 December 2021, there is still a negative 1.82% variance of the project, as the actual work progress was only 98.11% compared to the planned actual work, 99.93%. This negative variance indicates that the project is left behind the schedule. Earthwork have been fully completed, while the underground road tunnel still left some work to be done, such as the architecture work, 95.34%, and MEP works, 96.87%, and the finishes work, which are only under 83.20% of the work progress. So this is the summary. The client is the TRX City Sdn Bhd, Civil Structural Engineering, Ecom Perunding Sdn Bhd, EDP Consulting Group Sdn Bhd. The quantity surveyor that involved in this project is JUBM Sdn Bhd with Baharuddin Ali and Law Sdn Bhd. The project management for this project is the Turner International Malaysia Sdn Bhd, while the mechanical and electrical engineer is the Ecom Perunding Sdn Bhd, and the contractor for this contract number 2 is Khidmat Hijau Sdn Bhd. As what I have mentioned before, the site possession starts from 21st October 2015, and there is a difference between the original and revised contract sum. The revised contract sum has been decreased to 695,629,211 ringgit and cent 1. The original practical completion date was 7 September 2017, while the revised one is the 18 June 2019, and the latest completion date is 18 September 2022. The location for this project is Section 62 and Section 67, Jalan Davis, Wilayah Persekutuan Kuala Lumpur. For next part, I will explain about the function of the water reticulation system. The main function of this water reticulation system is to provide water for targeted consumer around TRX area. As for this project, this system will ensure all the buildings in Tun Razak Exchange will get water supplies all the time. This system is designed to collect and store water before it being treated and distributed to all targeted consumer. All the pipes and fittings will allow the system to supply clean water for thousands of people that will live in the TRX area. Enough energy is needed to flow the water along the pipelines, as the movement of the water will encounter numerous resistance. Elevation of the pipeline location can help to ensure that the water will move flawlessly. Second one is this water reticulation system should achieve the objective or requirement to become effective. The water reticulation system must have ideal pipe size, layout, and pressure pump capacity to provide to the feed load. During some peak season, this water reticulation system cannot be affected as it must supply enough water even during the peak season or peak hour. Water storage is an important component for this system as it needs to consider fluctuation and demand every time without any disturbance, and it will allow the system to become easier to maintain while the supply of water cannot be stopped. Next, I will talk a bit about the advantages of the water reticulation system. First one is the clean water. It is because the water has been treated and can be used for daily usage before supplied to all buildings in the TRX area. Next one is, as we know, this project will have the high pressure water pump. So this high water pressure will ensure the water flow continuously into all buildings. So those buildings will not need any pressure pump to supply water to every part of the building itself. Now we move on to the disadvantages of the water reticulation system. First one is leakage. If any leakage occur on the supply pipeline, it will affect the water supply and lower down the pressure of water. Next one is no alternative water supply. All areas covered will not receive any clean water if the maintenance of or repairing work of any part of the system is carried out.
Further with our case study, I'm going to explain the layout plan and the design need used in the water reticulation system. Regarding our case study, the project that had been chosen is the Tun Razak Exchange, also known as TRX. As shown in the layout plan, the proposed waterline for the water reticulation system covered the whole site, approximately 70 hectares. The design method for the TRX project is by using a ductile iron pipe with a diameter of 150 millimeters, 200 millimeters, and also 300 millimeters, and about 6 meters long for each piping. And they also use a mild steel cement line pipe as their main water piping with the diameter of 350 millimeters to 400 millimeters of diameter. For the main water piping, is a type of water pipe that is a part of the water reticulation system. Next, we go to the piping system. The piping system can be built with a variety of pipe materials, including asbestos cement pipe, PVC pipe, ductile iron cement line pipe, and lastly is the mild steel cement line pipe. For the asbestos cement pipe, also known as a transit pipe, it is a tubular cement liquid transportation vessel that is made of asbestos. The asbestos is used in asbestos cement pipes to improve their mechanical properties. However, as stated by the engineer Encik Azizan from the Ecom Perunding Sdn Bhd, he said that the asbestos cement pipe, which was widely used in the 20th century, has been mostly phased out due to health concerns. Therefore, in this project, they avoid using this type for the piping system. Next, we go to the PVC pipe. PVC pipe, we known as a white plastic pipe that is commonly used in plumbing and also drainage systems. For the plastic piping, is becoming more popular as an alternative to metal pipes because of because it is made of polyvinyl chloride, and due to its strength, durability, ease of the installation, and the low cost of the PVC, had been one of the most commonly used plastics in the world. PVC also is a thermoplastic material that can be molded into a variety of shapes to make pipes, fittings, valves, and other liquid handling supplies. Next, we go to the ductile iron cement line pipe, also known as DI pipe. Okay, DI pipe is a type of cast iron pipe that is commonly used for potable water transmission and distribution. For our case study, the TRX project mainly used the ductile iron pipe as said by the engineer Encik Azizan. The ductile iron pipe is used when the diameter of the pipe reach until 12 inches to make sure that the water flow is at the right pressure. This pipe is a direct descendant of earlier cast iron pipe, which had been supplanted. The ductile iron used to make the pipe is distinguished by the spheroidal and nodular nature of the graphite contained within the iron. Centrifugal casting in metal or resin line molds is also commonly used to manufacture the pipe. And lastly, we go to the mild steel cement line pipe. It is created by coating the internal section of the pipe with a mortar-like compound that acts as a barrier between the carbon steel pipe and the process. Mild steel pipe and fitting are commonly used in the transmission of potable water and for the sewage. It is also used when the process fluid has a high likelihood of corroding standard for the carbon steel pipe. Next, we go to the design method for the water reticulation in our case study. Okay, due to the flat layout of the plan, the type of design for the water reticulation system for the TRX project used is a combination of flow gravity system and also system under pressure designed. The treated water is pumped at a set rate to be stored in water storage at a high level. The system works when the storage tank is made through the force of gravity. The water will be pumped through all the pipelines according to the stage of the water pressure as per the diameter of the pipes. The smaller the diameter of the pipes, the water pressure will be higher than before, and it is the most often used because of the effectiveness factors and the low cost usage. Next, following the pipelines network system for the TRX project, which is the dead-end network system, this method is also referred to as a tree system, and it is made up of a single supply main, from which submains are drawn, and the branch lines are provided from the submains from which service connections are provided to the consumers. And also, the layouts dead-end system is used in areas that have grown haphazardly. And lastly, we go to the useful life of the pipe. The useful life of water mains is determined by the variety of factors, including the material type, construction practice, and so on. And we can see from the table shown in the slide, for the pipe material, asbestos cement, the typical life for the useful life is between 40 years until 65 years. And for the PVC pipe, the typical useful life is between 50 years until 75 years. And for ductile iron pipe, is between 80 years until 100 years, and same also with the mild steel pipe, which is between 80 years until 100 years.
Moving on to the components and materials used in a water reticulation system in TRX project. The first main component is the pipe. The material of the pipeline being laid in the trenches is mild steel cement line pipe. The diameter of the pipe involved in this project is 100, 150, 200, 300, 350, 400, and 450 mm diameter of pipe. It also follows the standard for mild steel cement line pipe, which is BS5341990. Also, the mild steel pipes were installed and equipped along with the thermal insulation to protect it from the heat. Secondly, the sluice valve. The sluice valve is a component in the water reticulation system which is used to regulate the flow of a pipeline. When repairing is required, this valve shuts off the water supply beyond the valve in the pipeline. The diameter of the sluice valve involved in the project is 100, 150 mm diameter, 200, 300, and 450 mm diameter. Next, sluice valve with electrical actuator is also involved in the component of water reticulation system. So the function of sluice valve with electrical actuator is to assist in achieving remote control function and increasing the production efficiency. The function of the valve actuator is to open and closes a valve which is primarily used to connect or disconnect the medium in the pipeline. The next component is core valve. They are irregular valves that can be operated by hand. It is installed in each depression in a pipeline. Residues such as mud and sludge accumulate in the pipes at this depression, which commonly occur when pipe cross valleys. When the valve is turned on, the high velocity of the water removes the dirt. Next off, we have the mechanical coupling plane and joints. This is the type of the jointing used to connect the pipeline. It offers a method of providing joint restraint with a standard mechanical joint socket of a pipe, fitting, valve, or other product. The coupling and flange adapter will be used in pipelines as mechanical pipe joints to remove valves and fittings without disrupting the pipeline and to accommodate minimal ground movement, expansion, contraction, and angular misalignment. On top of that, this project also used double air valves. The double air valves are installed to automatically remove the accumulated air. During filling operations, large amounts of air are discharged. Besides, double air valves also allow a small amount of air to escape during working operations and allow air to enter during piping emptying operation. The installation of double air valves are complete with necessary brackets and flexible joints. In this project, they also installed a water quality sensor. The sensor is specifically designed to enhance the management and the control of the quality of the water distribution network. It is also used to monitor the important water parameters chlorine, conductivity pressure, and temperature using innovative and integrated technology. With water quality sensor, it can be used to detect any changes in water quality commonly caused by leaks, pipe corrosion, and befouling effects. Next, water meter is also installed in the water reticulation system in the project. Basically, water meters are installed to measure the amount of water flowing through the pipe. The last component of the water reticulation is the chamber. The chambers were built to store the components with an adequate measurement of size to allow any maintenance action to be done by a technician which at least fit for one person. The table above shows the type of chamber, the size of the chamber, and the total number of the chamber involved in this project.
So moving on, we will look at the plant and machinery that are involved in the construction of water reticulation. Firstly, we have a backhoe loader. Backhoe loader are widely utilized and can perform a wide range of activities. So generally, a backhoe loader consists of a tractor, a loader, and a backhoe. Next we have is excavator. So excavator is commonly used during excavation work. So for water reticulation work, excavators are used to excavate trenches for the pipeline. Other than that, we have the tipper truck. So a tipper truck is used to transport excavated materials to dispose of or to fill. Next we have is mobile crane. So mobile crane is used to lift any components of water reticulation such as the pipes or even the precast concrete works. Next we have is bulldozer. So a bulldozer is a tractor unit with a blade attached to its front. So the blade is used to push, to shear, cut and roll materials ahead of the tractor. Usually following up the bulldozer are the grader. So grader is a narrow multi-purpose construction machine that is used to flatten a surface during grading a project. So usually grader is used before excavation work starts to flatten the surface and to get rid of any small obstacles. Lastly, we have the compactor. The compactor is mainly used to compact the backfill in the narrow trenches. Now we will move on and look at the equipments that are used for reticulation work. Firstly, we have the spirit level. So spirit level is used to make sure that the pipes are aligned at a suitable degree. Next, we have heavy duty wrench, which is used to fasten the bolts and nuts in between connecting pipes. The third one is the crowbar. Crowbar is used to help fix the pipes into the right position. The fourth one is welding set. So a welding set is used to join two pipes together, or we call it the pipe welding method. The fifth one is cutting torch. Cutting torch is a tool that is used to cut and working with metals. In this project, it is used to cut pipes, specifically the mild steel cement line pipe. Lastly, we have hydrostatic test pump. So this equipment is used for a hydrostatic test. The test is carried out at a pre-commissioning stage prior to the sterilization stage. This is used to determine the integrity of the pipe, the joints, fittings, and other components, and this will highlight any leak if it have any leakage. On a construction site, labor refers to the people who do the construction job. So labor on site can be categorized according to their scope of work. In the construction of water reticulation, there are different kind of labors involved, such as number 1, general construction worker. A general laborer or general construction worker is responsible to perform various tasks to aid the daily operations at the construction site. Second is the plant operators. Since our project has a lot to do with have a lot of plants and machineries used, so plant operators are very important because they are in charge of running the heavy machinery and equipments that is utilized in the construction site. The plant operators will operate the machineries that is used for digging trenches, to excavating, breaking rocks, and moving materials. The third one is signalmen. So signalmen, since we have plant operators, signalmen is a must because, for example, during lifts, a signalman serves as the crane operator's eye and ears since they have the finest view position and assessing and also directing how the load to be moved. So to avoid any crane mishaps, they must communicate with the operator. So as a signalman, they should also be a qualified seasoned crane operators. Lastly, we have pipe layers. So pipe layers are workers that put down pipes as a part of the initial groundwork for construction. So cutting lengths of pipes to build a system is also one of the components of the pipe layer's job. Pipe layers must be able to do a variety of tasks ranging from heavy equipment operation to uh, to blueprint interpretation in some circumstances. Welders are also common among pipe layers because it is important to note that the welding process that is used to join pipes are not as the same as other form of welding.
Next, as for the construction process for water reticulation piping installation, it consists of several phases such as surveying work and setting out, site clearance, excavation of trench, bedding for pipes, pipe works, embedment and backfill, testing of pipe before the pipe is ready to be used. So firstly, it started by preparing and obtaining relevant information such as the topography and the location of the construction site, which is the first step. We need to identify the characteristic of the surface, the area, the shape, and the ground level of the construction area. So by doing so, the contractor will be able to commence the work safely and diligently according to procedure given. Not only that, it is also necessary to conduct a location survey in order to identify the road accessibility for the transportation and the equipment as well as the material. A drawing for the installation of water pipe area shall be approved by the involved parties such as Shabas and SPAN. Not only that, a list of specification of the structure, the material, the equipment used should be included in the drawing. Any work or information prior to work shall be aligned with other construction party as well. Before the commencement of the excavation work begins, the process of site clearance should be completed first. Hence, it includes of removing all sort of vegetation, trees, or any unwanted debris in the construction area. Thirdly, after the layout of the piping road has been set, only then the excavation of the trenches can be carried out. The excavation process should follow the requirements such as the length, the width, the depth, slope, or any curve which is required in the project description and specification in the drawing. During the process of excavating, superintendent officer or SO need to supervise their workers' tasks. In order to provide a strong, solid foundation, the bottom part of all excavation areas shall be carefully cut and leveled in a range of 1 meter up to 1.6 meter below the ground level by using an excavator. This process is known as cutting. Later on, a tipper truck is being used to transport the excavated material in order to be disposed or filled later on. Next, before laying the pipe, all fill and the distributed area should be compacted to a density of natural ground. But before spreading the bedding, all debris, rocks, water should be cleaned from that area. A non-cohesive granular bedding with a minimum thickness of 75 is used for pipe other than PVC or PE pipes. As for the pipe work, once the excavation process has been done, the excavated area of trenches need to be maintained and cleaned from any debris, rocks, or water before laying the pipe into the area. All pipes and fitting must be laid in accordance to a specific type and rules as shown in the drawing unless otherwise is instructed by the engineer or SO. Firstly, the pipe connection must be fillet welded and the pipe fitting connection must be flanged and jointed using bolt and nuts. This process of laying and jointing of pipe must be carried out by the pipe layer workers as they have the knowledge and experience of welding and join for both pipe together. Next, There are some pipes connected through a socket and spigot method, and it is important to let the surface of pipe is clean using wire brushing before the process takes place. This is because the surface of pipe might be covered with a previous lap of welded joint or otherwise, which is it turns into a slag and it can hinder the smoothness when both pipes are fused together, as this will cause a jointing to loosen up and it might lead to a leakage slowly and become a major leakage. By this means, the spigot end needs to be pushed inside such that the spherical surfaces are in contact and the space between the pipe must not exceed 1.5 mm. As for the jointing of pipe using sluice valve, the flanges and the valve on the pipe must be inserted and tightened using bolt accordingly, and by laying the scour valve with the double air valve, and the laying pipe will continue increase the level despite any slight defects in the ground surface. Bolts are inserted to ensure the jointing is tightened. Bolt and nut will be used in order to connect the pipes to the chamber pipe, the quality sensor, and as well the flow meter pipe along the piping. After the process of laying and jointing of pipe has been done, a sufficient amount of backfilling into the trenches is required. This will prevent any movement of position for the pipe when the high pressure of water is applied and flows into the pipe. The material used for backfill must be free from stone, rocks, or any other hard materials, and the embankment material will be placed uniformly alongside the length of the pipe. Next, the surface will be compacted using a compactor or a roller machine once the thickness of the backfill layer reaches 300 mm thick above the pipe. And as for the last phase is testing of pipelines, where the test will be conducted with a presence of representative from the consultant, engineer, or shabas, where the contractor is responsible for providing all necessary equipment and material for the testing operation to be conducted. And as for the pavement, it will only be made once the pipe has been successfully tested. The testing will be conducted over 2 kilometers unless the engineer instructs differently, and before the test begins, all valves must be tested in order to ensure that they are in working order. Thus, the consultant should determine the test pressure to be applied during the testing, where they normally use 1.5 times of the working pressure with details as shown in the drawing or instructed by ER. Next, the pumping of the main pipe must be filled with clean water and the pressure must be increased by pumping into a specific test pressure after 24-hour period. The pumping will be then stopped 3 hours or until the pressure drops 9 meters. If the leakage does not exceed 10% of the working pressure earlier, then the main pipe is considered to be passed the pressure test and ready to be used. So, the contractor needs to identify and repair any leaks formed during the pressure test or after that, as well as to make goods of any joints to the client requirement where retesting is required if the client says so. Therefore, all testing will be only inspected by the consultant, who will then issue a certificate that certifying of the pipeline to pass the pressure test. Therefore, a constant checkup is needed for the contractor to monitor the performance of the pipeline as well as to avoid any leakage happening in the future.
Next, let's look into the construction planning and management. As we know, the project management has become a key factor in how construction projects should be carried out. This is to ensure that the construction project has a greater continuity in terms of its operation. Hence, some of the factors should be considered in the construction planning and management are safety and health, construction material management, construction waste management, and also human resource management. Let's start with safety and health. In terms of safety and health, a construction project should have a safety and health policy. Every employer shall prepare a necessary revise a written statement of his general policy regarding the safety and health of his employees at work. Secondly, a construction project should also have an occupational safety and health management system. The employer must indicate, accomplish, and sustain an occupational safety and health management system that meets the requirement of the relevant Malaysian standard in construction. Plus, a site supervisor must also be in a construction project. The main contractor of a work site must appoint a part-time site safety supervisor who must devote at least 15 hours per week solely to safety supervision and promoting safe work practices on the job. Lastly, a safety and health officer is also important to ensure the safety and health in the construction project. When the total contract price of the project exceeds 20 million ringgit Malaysia, every contractor of any building operation and works of engineering construction must employ the safety and health officer. Now let's move on to the construction waste management.
Construction waste management. Construction waste is created during construction or during remodeling, repair, and demolition of buildings and infrastructure work. Construction and demolition garbage or waste is made up of wood, metal, concrete, bricks, tiles, and mixed waste. Construction costs have risen and resources have been wasted due to lack of effective and inadequate waste management technology. Construction waste should not be disposed of immediately. Instead, it must go through several procedures before being disposed of. It should be dealt with the following waste management hierarchy that was proposed in a study by Peng in 1997. According to the waste management hierarchy, waste should be produced, reused, and recycled before being disposed of and properly, such as in the landfill. As a result, the landfill's life expectancy will be extended. Following the waste management hierarchy steps benefits a country's ecology and economy. From a legal and enforcement standpoint, construction waste management is important. It is necessary to have a competent legal structure in place to provide a framework for everyone involved in the building sector. So to ensure that the system is in place, enforcement must be used to provide a deterrent to those who do not follow those rules. Malaysia's ability to cope with future sustainable growth depends on its ability to manage construction waste. The country should aim to employ a waste management hierarchy strategy instead of the current waste disposal technique, which is not sustainable. The strategy will aid in the reduction of negative environmental, social, and economic challenges.
Next, we go to the construction material management. In the construction industry, construction materials management refers to the process of planning, carrying out, and controlling field and office activities. The purpose of materials management is to ensure that the construction supplies are available when it's needed. And also, the materials management system strives to ensure that the necessary quality and quantity of the materials are identified, purchased, delivered, and also handled on site in a timely and cost-effective manner. The materials management is the system for planning and controlling all the efforts required to guarantee that the correct quality and quantity of materials are specified promptly, and it is also to procure at a reasonable cost and most importantly, available at the point of use when needed. And as a result, materials management is a crucial aspect for the project management, and materials are a major expense in construction, so lowering the procurement costs increases the chances of lowering overall project costs. However, poor material management can lead to increased building costs, and it is also efficient material management can result in significant cost reductions on the projects. If supplies are purchased too early, capital may be held up and the interest payments on excess inventory may be incurred. Next, given the influence of the workflows and profitability, investing in the materials management system can enhancement and also have a major positive impact on overall construction management efforts. Among the several advantages of the construction material management are, firstly, is the increased worker productivity. It is when the labor costs are a popular target for cost-cutting techniques in the construction sector, and it is the most popular strategy to accomplish these cost savings in to reduce the employee hours and wages to the greatest extent possible. However, worker productivity is frequently neglected as a cost-cutting measure, and is effective material management can play a significant role in increasing the production. Secondly is to reduce or eliminate material handling or duplication. For this advantage, a good material management system contains tools or effective communication, scheduling, and also tracking. Sites are prepared for the items and they can be deposited and stored in the most convenient area. This level of management ensures that workers aren't spending time transporting items and equipment that are not required. The third one is to reduce the risks of theft and also weather damage. The souvenir materials can be used after they arrive at the construction site. It is better, and this is especially true when they want to secure or weatherproof the storage facilities are scarce. However, accurate scheduling as well as acquiring the correct number of building materials decrease the amount of time they remain unused on a job site, and this will be reduce the exposure to the environment and potential weather damage as well as their vulnerability to the theft. For the fourth advantage is reduce material waste. Is an effective material management system to ensure that materials are not only at the right place, but also at the right type and also the quantity are obtained in the first place. Selecting the wrong building materials can cause a variety of issues, ranging from small delays to safety hazards. Incorrect materials can also result in contract fines if they do not fit the project requirements. And lastly is to improving the budget, accuracy, and also forecasting. Even when things are going well, the materials and labor account for a sizable amount for construction project expenditures. However, when the difficulties arise, these expenses can skyrocket as a result of decreased production and also project delays.
Human resource management, or also known as HRM or HR, is an approach to manage people, the culture, and the environment within an organization, where it focuses on the employment, administration, and the overall goals as well as the direction of an organization. So the basic roles of HRM and their responsibilities consist of 7 aspects, which is the first one is forecasting. HR manager duty and responsibility includes working with the construction manager, project manager, contractors, engineer, architect, or any other party involved in the construction. And by doing so, the number of labor can be estimated. The second one is in recruiting and hiring workers and label for each project, HR will be in charge of selecting a better fit for the descriptive job required, as they will select and choose the qualified candidates along with the experience and necessary skill needed for the job offer only. As we are all aware that the construction works entails a wide range of specialized jobs where in reality the ideal candidate for this position will be limited. The third one is training. Workers will be trained and licensed in accordance to their scope of work in order to execute their duties properly. The workers are required to use any necessary equipment so that the satisfactory level of performance of the criteria of the construction project can be met. The fourth one is compensation. As HR, they need to assist their organization by providing a competitive compensation and benefit, as HR need to provide such healthcare plan or insurance plan for their workers. The fifth one is compliance. As a professional HR, they need to stay on track with current issue on the migrant safety and OSHA regulation, as it will provide a solution for risk management issue that will occur in an organization. The next one is worker safety. It is a major concern when it comes to safety aspect, especially on construction site. HR need to ensure that their organization has taken all the necessary precautions to be implemented on the site for the workers as well as the laborers. The last one is employee retention. Losing skilled workers during the construction period will cause the construction company potential to be lowered. Thus, HR should develop a solution in order to resolve it by giving an incentive for the workers to continue working until the construction period is done. Therefore, in order to demonstrate and achieve competence team of organization in a project of work, HR need to play their roles diligently. And there's a saying goes by, the success of every construction project depends on the worker and the manager who completes it. In conclusion, the water reticulation system is a system that collects and treats the water before distributing it to the networks and consumer, where it is usually being delivered through an infrastructure. There are few considerations that need to be highlighted on, such as the sizing of pipe, specification, material, location, the component, the future expansion and the risk or probability of leakage, the maintenance, as well as the management. As mentioned earlier, the location of our case study is located at Tun Razak Exchange, where the structural engineer in charge of the construction are JUBM, Sendirian Berhad, and Baharuddin Adi. This reticulation system does bring some benefit to the consumer, where the water has been treated before being distributed to the consumer through a high water pressure flow, and thus the consumer will receive it faster. However, the drawback of this water reticulation system are when there are any maintenance repair works due to the leakage, the consumer will not be able to use the water supply temporarily. And there are several types of pipe to be used in this project, such as asbestos cement pipe, polyvinyl chloride PVC pipe, ductile iron cement line DICL pipe, and mysteel cement line MSCL pipe, where it includes a variety of jointing to be used to. And for the construction process, it started with the process of surveying work and setting out of the proposed site area up till the testing of pipe before the pipe can be used. And there are several plants and machinery to be used, which are commonly seen in the construction areas, such as the backhoe loader, excavator, tipper truck, mobile crane, angle grinder, heavy-duty wrench, crowbars, and spirit level. So for the last part, there are also four important aspects for the construction planning and management, which are: first one is safety and health, construction waste management, construction material management, and human resource management. So that's the end of our presentation, and thank you.